Welcome to Dr. M's Vodcast, a vodcast with a mission to connect continuous improvement professionals across the world.
Welcome and namaste. Thank you, Jackie, for being here with us on a Sunday evening and daytime, and I don't know what time is it elsewhere. But then it's been the third episode now, and we are going to talk about the improvement cycle. And because I got a nudge from Jackie, and everybody knows Jackie, but I got a nudge from her last time. I said, "Do everybody know me?" I said, "This time I'll do one thing. I'll introduce her." I said, Jacqueline Graham. She's a chemical engineer, and she's been with Deming for the last 5 years of his life. She has been awarded the Durand Medal, and she is a managing director. And I don't know how she manages. She manages the business. She's always there whenever we want her on Deming. And for me, she's the guardian of Nest. So what we're going to talk about, episode 2, is the improvement cycle. And without getting more into your airtime, Jackie, handing it over to you.
Okay, I'm going to share, and then I'm going to try and let's see how all this works.
It works. There we go.
Did that work?
Yes, ma'am.
Oh, that's good. Except I can't see you guys anymore, but that's okay, I think, maybe. Okay, so that's just a picture of me with Dr. Deming. You've all seen it before, and it's on the background as well. So just a reminder why we're here. Every meeting we are here to learn, to have fun, and to make a difference. So what I'm talking about this time is the improvement cycle. What I want to focus on probably for the next couple of sessions is some stuff that you can do no matter who you are. If you're a leader of an organization or if you're further down an organization, tools that you can use. Right, so the improvement cycle, you might know it as PDCA, you might know it as PDSA, you might know it as the Deming cycle, you might know it as the Shewhart cycle. How did it get so many names? One wonders, right? So for something, it's very profound and simple in concept, not necessarily in application. Online, and this is actually on the Deming Institute webpage by Moen, and he talked to the father of modern science and Galileo and Francis Bacon and his work on inductive learning and how it went into pragmatism, etc. And the big influencer for the improvement cycle was actually C.I. Lewis. Integration and pragmatism and empiricism. Now, he wrote this book, Mind and the... Whoops. Oh, that's challenging. I'll just describe it as Mind and the World Order. Influence on Deming. Deming was still studying this book in the latter parts of his life. I remember him reading it when we were working together. So from this, Shewhart developed what is called the Shewhart cycle, which I will describe more. That then led on to the Deming wheel when Deming was working in Japan in the 1950s. And he further developed that to be called the Shewhart cycle and what we now know as PDSA. Meanwhile, in Japan, they called it PDCA, and it's talked about more as PDSA. And in international and Australian standards. So let's just understand a little bit about this. What is it trying to do? Is there really a difference? Okay. So this is the improvement cycle as proposed by Shewhart back in 1939. And what he was trying to do was say, we can't just set a specification, send it up to people to produce it. Right? It should not just be a start-stop process. It actually has to be a cyclic process. Now, I have a customer that suffers from this greatly. They have an R&D department who create these amazing designs that they're supposed to produce. When they go out into production, they can't get anywhere close to the designs. And they struggle to make those designs on the long term because of the way they've been designed. And the only way around that is to think about it in a circular fashion. So you create the specification, you go and produce it, you inspect it, but then you use that to feed back into the specification point. So this was Schuhart thinking about this as a very cyclic process, and it is the origins as we know it of the improvement cycle. So it's proposed as a dynamic scientific process of the way we acquire knowledge. So how do we learn? There's a lot of theories out there about how the brain works and how we learn. But what's for sure is if we have a theory, we test that theory, and then we learn from that. That is one way of getting knowledge and becoming more knowledgeable. So the cycle will keep turning. That's the concept that Schuhart tried to get across. That cycle keeps turning until production and specification are optimized around what the customer needs. That's what was at the background for Schuhart. So the concept is we learn, then we adapt, learn, change, but keep refining. So if you think about communication, you know, the way we used to talk, and then we got telephones, and then we got fax machines, and we got computers. It'd be interesting to think about whether communication's improved or not improved through all those iterations. I'm not so certain that it's completely improved for those iterations, but it's about feeding in, learning more, adapting, changing, feeding more. That's what we want to do. So we have a new theory, we test that theory, and then this is the important part, that we review whether we were right or wrong, and then we learn from that. For me, this is often the bit that's missing, so the learning doesn't happen. So let's go to Deming back in 1950. This is basically what he took to Japan. And what he took was, let's design the product in step one. Then we make it, put it out on the market, and then test it. Did it work? Is it what we wanted it to be? What did the customers think of it? Do we need to redesign? Do we need to refocus on what the customer wants? How does that sit? And that was the cycle that Deming first showed in Japan in the 1950s. The Japanese took this to the PDCA cycle, as we call it, the Plan, Do, Check, Act cycle. So the phases are fairly straightforward in that we plan a change or test to include data. This is just a fundamental part that is often missed. If we want to go out and test something, we actually have to go and collect some data. So collect the data, the information you're going to need to show if you improved or not. Then carry out the plan, ideally on a small scale. Deming always emphasized this, that, you know, you should, whenever you possible, you should go away and trial. You shouldn't just go diving into a massive improvement that may not work. Check, how did it work? What did you observe? And then act, review the results. What did we learn? And feed that back into the cycle. So in 1986, Deming refined this a little bit further. And what you will now notice is that he's got study the results. Okay, so observe the effect of the change and study the results. So here it is a little bit further along the line with the Plan, Do, Study, Act cycle. So why did Deming get very passionate about talking about study rather than change? If you want to talk in the chat, please do. I'm really wanting this to be as interactive as we can, not you just sit here and get bored with me talking, right? So why would he suggest study over check? What do you think the difference is? Why is it important? Because it is really important. Are we getting any chats? I don't see any chats. Somebody talk? Anybody want to talk? Why is study different to check?
Yeah, check seems to be a one-off activity.
Yeah, so it's kind of it's one off. It's did it work or didn't it? It's not did it work? Did we impact others? Did it work? Do we have the capability to keep it working? Check feels very superficial. And that was the way it was being interpreted. I think check in Japanese culture, I don't think the translation has worked. So I think the translation would be more of study than check, because the way the Japanese do it is not check, tick in a box, but it's more of a study, the holistic system. Did it work? So it was Deming revised this back in 1993. And he produced this gorgeous little cycle, the helix. So the helix, it's really funny because for many years I saw this very different to what it actually is. So as you, some of you know, I do 12 days of study groups based in Australia. And it wasn't until somebody pointed out to me that the arrows are going outward, not inward. Because I thought, oh, the knowledge is getting refined and more refined and more refined as it goes in. But actually, the correct interpretation is as it's coming out, you're gaining and gaining more knowledge. So it's actually quite interesting how you can misinterpret it and see something else there. But that's what it's about. It's about gaining knowledge, understanding, and optimizing your system. So it's not about let's go and make a change and that's the end of it. It's about that continued review, whether we're in the right place, whether we need to further improve. So the improvement cycle isn't just a one-off. This was my AI. This was my experiment with AI. Show me a plan, do, study, act cycle going up the hill. It took me a long time to persuade the AI that I needed to study, not check, which was kind of interesting. But what you see here is the person pushing up the plan, do, study, act cycle up a hill, because quite often it's quite difficult to make those changes. What's really important is you can see a wedge in the bottom of that wheel. That wedge is really important, and the wedge is nowhere near big enough. I just not talented enough in AI to make it bigger, because the biggest issue I see is that the cycle goes rolling back down the hill again. And I'll talk more about that and what the pitfalls are in a few moments. But yeah, you can think of the person continuing to turn the cycle, continuing to turn the wheel, going up towards their optimization. Often people think that this is Demaic. And it's not that it isn't, it is. What I concept that's simple, very complex. And I want to crack it back to its simplest point. Because in Demaic, you define your measurement right here and you go off and measure it. So just that action of going out, creating measures, measuring and getting feedback on that is an improvement cycle in itself. So inside Demaic, I would say that there are several improvement cycles all the way littered through the Demaic cycle. And what I wanted to say to people is try not to get overly complicated about this. This is a really simple concept that you have a theory and you define it. You go out and test that theory, you study it, and then you act to learn from that theory or go appreciate that you need new. So think about it in its simplest terms. It can be as simple as, learning a new skill, learning a new cooking skill, or learning, how to ride a bike, or it's a very simple concept. So I don't want it to be overcomplicated. I want you to think about it and tear it back. So pitfalls. There are a number of pitfalls to the plan, do, study, act cycle. So let's start discussing some of those. So in the plan phase, right. Often what happens in the plan phase is people totally underestimate it, don't allow enough time for it, and then we have poor planning. We have a saying in Australia that I won't repeat because it's a little rude, but basically if you don't do this bit well, then everything else goes off, right? Nothing works. If you plan poorly, you execute poorly. And so planning should be the biggest stage. This should take the most amount of time in general. Often what I see is it takes the least amount of time. So if you cut down your planning time, you are going to make sure that you do a lot of work in study and act. And the time that you spend later in the cycle will be far, far more than if you'd spent a decent amount of time and really thought through the process first at the front end. So this is a problem that people underestimate the plan stage. So cutting time, it just leads to problems later. During the plan stage, we should try and anticipate the issues that we face. So what could go wrong? You need to challenge that. What could go wrong? What might not work right? What might destroy us from learning? So consider that. And everybody has to be on the same page about why we're doing it and what their role is. Again, often this is poorly rolled out. So if you want to learn as an organization, you have to be in it together as an organization. You have to work out who's going to do what, what's important, and make sure everybody understands that. This is part of the planning phase. And you need to make sure that you know that how you're going to demonstrate later how you improved. So I don't want you to be in a situation where, we improved. And somebody else says, really? I didn't see any improvement. All right. So you're convinced of the improvement. They're convinced you haven't improved. You're now subject to the grapevine. That's not what we want. We actually want proof that you've actually improved. So in the do phase, this is my favorite bit that goes wrong. Oh, maybe I should say my least favorite bit. And that involves invalidating the test. So in other words, you don't follow the plan, right? And this has happened to me a lot frequently, right? People don't follow the plan. So had a situation where we took a piece of equipment down. We had it down for 24 hours while we implemented this change. This is a 24 hours a day, 7 days a week, every week of the year. They don't even stop for Christmas Day. And we had this piece of equipment down for 24 hours. And they couldn't resist it. While it was down, why don't we do this, 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 this? So we had the bit that we were changing, but then lots of other things got added on as well. And so, of course, when it did work, was it the bit that we changed? Or was it one of the other bits? So if we run into the same problem again, do we just do the bit that we think made the impact? We don't know. The answer is we don't know, because several things occurred at the same time. All we know is the combination of those several things worked. I was in a factory in Asia, and one of the people I was working with said to the operators, well, I hope you didn't bow at the sun at the same time as you made the several changes that we didn't discuss. Otherwise, we'd have to bow at the sunshine every time we want this process to work as well, because we can't eliminate it. Right? Now, that sounds ridiculous, but you stop the learning. As soon as you make a slight change from the plan, you've now stopped the learning. So think about it, right? Making several changes at the same time just leads to conclusion, and you're not understanding which bit improved and how it improved, how it works. So the next part is the study. And obviously, as I was talking about before, it's that quick check. Did it work? Yes, no. Did it make a difference? Now, you have to understand what normal variation for this process is. Otherwise, you will never be able to work this out. So towards the end of last year, we talked a bit about control charts, but you need to understand what the normal variability in the process is, because maybe it's just an improvement. Those of you who've done the red bead experiment will know that we can celebrate people getting fewer red beads. We can celebrate success very easily, and then it becomes normal variability. And this is the frustrating part when people are celebrating success, which we know is not really a significant change. Because what we're looking for is it a significant change? Yes or no? Or did we just have a good day when we did the test? We need to understand the difference. So statistically, we've got to get to grips with that. Not looking around for any negative effects. That's the other aspect. So, yeah, we improved, but maybe several areas in your organization now hate you, right? Because it worked for you, but now you've made their role harder, right? So one of my favorite examples of that is a company I'm working with. They do road maintenance, and they changed one of their systems. So it was semi-automated, that instead of manually showing where potholes were on a map, you now do it through a tablet, hit the point, it drops a GPS point, and the IT people thought, well, while we're doing that, we can ask them what size it is, whether it needs traffic control, a whole series of questions got put in. Now, if you are in a small street where you can stop, do all that, works perfectly. If you're on a what we call a freeway or a motorway, when you're going at high speed, so we have roads here where you can travel at 110 kilometers an hour quite legally. Are you sure you always going to drive legally before? So you could drive quite legally at 110. How do you drop a pin and answer all those questions while driving at 110 kilometers an hour? So what are you going to do? Come off, go round in circles until you drop the pin in the right place? It's just not feasible, right? So it might be that you've made the communication to the crews really look really good, but it may also mean that the people who are doing the work have now got a situation that's intolerable for them. So this is the biggest pitfall of all, the ACT, where generally people just move on. Oh, that worked, great, let's move on. Right? They don't lock in the learning. And what we want to do is think about that wedge. You saw the uphill and you saw the wedge. And what we want to do is make sure, how do you wedge it in place so you can never go back to the way you did it before? How do you stop it, prevent it? And I think this is the bit that people like the shiny stuff. Oh, we did the experiment, it worked, shiny stuff. Oh, now we've got to write standard operating procedures and lock in the improvement. Oh, that's boring. And it wanes and they don't do it. And then what happens is a few weeks ago, I got a phone call from a customer and they went, remember about 5 years ago, we made some major improvement and it was really good and we were really happy with it. Well, we got the same problem back. Sorry about that. We got the same problem back. And we can't remember how we fixed it last time. We're hoping you've still got the records. Right? It's not my job to keep an organization's records, right? I was so disappointed because we'd spent a fair bit of time trying to make sure that happened. And obviously it didn't. So don't get into the same situation. Otherwise, you have to hire the consultant again. Right? And this time there was a penalty on my fee, because I'm telling them for the second time, or I'm helping them for the second time with the same problem. It's not what I like to do. I like new problems, not old problems. So, not recognizing the learning in the organization. I actually see this as a pitfall that the organization doesn't recognize that we've learned and that we've improved and doesn't celebrate it. Celebrating success is really important. So people who've worked really hard, they deserve that recognition of learning, deserve that recognition that they've moved they've moved the compass point, they've moved where you're at. They deserve the recognition. And also whether this should occur whether it worked or not. And this is where people struggle. When something's worked and you've got a big improvement, people are more ready to celebrate. When it's not worked, people want to run away. And we should not be doing that, because if it didn't work, you have learned something more profound than you probably would have done if it had worked. So in cement manufacturing, I was working with a customer, and they were locked into a relationship between two aspects of production, and they'd been locked into it for a long, long time. And they ran their plan and their systems around this relationship. And I think potentially decades ago, that relationship existed. But when we tested it recently, it didn't anymore. And that actually unshackled them from having to maintain that, and led to significant productivity improvements. And the only way you could get through that was by showing it wasn't the case. It didn't work. So sometimes you will learn far more from failing than you will from an improvement. And they need to be celebrated whether you've failed or you're improved. The fact that you are trying to take the organization forward, or you're trying to learn as an individual, is important. Inadequately recording the learning, huge, right? And I think it's got harder. It might sound strange, but I actually think it's got harder with the IT world, not easier. Decades ago, when I was auditing for General Motors, I would be able to walk into a quality department of their suppliers. I used to do supplier quality audits for General Motors. I'd be able to walk into their quality department. I would be able to find all the records of all the tests, everything. I would be able to find improvement projects. I would be able to find corrective analysis. I would be able to find lots of things. Now it seems to be a challenge how we record it, how we retain it. It doesn't have to be complex, but you need a method of how you retain knowledge in your organization. It's part of a much bigger thing. In Australia, we're getting to the point where a lot of our industries are 50 years old, and the people who founded those industries are retiring. And we're finding that the knowledge is a problem of passing it on to the next generation. Part of that is people have retained knowledge themselves because they see that as an aspect of power, right? If I've got the knowledge, the next round of redundancies, you're not going to touch me because I've got this knowledge, right? And you know it, so you're going to keep me because you need my knowledge, right? So I'm going to retain that really close to my chest. So the part of it's that. But part of it is just a lack of systems to help you record where you've learned. In Japan, they have the A3 system, or in Toyota, they have the A3 system, which is a simple A3 page which summarizes an improvement. But how you file those so that other people can find them later is the really critical part. So that how do you find stuff that you've learned previously? It's a huge question that needs to be answered. So you have to operate that whole cycle: plan, do, study, act. And it needs to operate in order for you to learn. If you cut off or go to one side, you won't. So as human beings, we tend to have a bit of a focus. We can be a plan studier, so very much a theory person. So I don't go out and do it in the field. I'm very much recently somebody on our 12 days course from Mexico was saying, he works in a university there. He was saying, I say to my students, this is the theory, but you tell me what you find when you go out and apply it, because I need that information. I need that information coming in. Recognize that I'm stuck in plan study because of my role in a university or a college. I'm not doing the do act. And then the opposite, the do act. Engineers are really bad about this, right? As engineers, we love to just take things apart, plug them in, hope it works. I'm sure I can work this out. We pull things apart, we put them together a different way. We love it, right? I'm going to be doing it shortly because there's a radio that's not working and I'm going to have a go at fixing it. So we'll see how that goes, right? But we love doing that stuff, right? I have poor planning on this as well. So I can't find any manual for this. So it's going to be an interesting challenge. But we love that. Those of us that are in that do act. But we don't learn. If we do, and then we get success, we haven't learned anything because we had no theory going into it. So I think people have a natural inclination into one or the other. So you have to think about, what is my natural inclination, and am I doing the other parts, and how do I manage those other parts to make sure I actually do learn, right? So the learning will be halted if you're not doing, and the learning will be halted if you do lots of doing, but you're not studying or planning. Locking the improvement in place. Make sure you lock the improvement in place. That's absolutely critical. Otherwise, there was no point in doing any of it in the first place. Going back to what Deming called this cycle, he called it Schuhart's cycle after Schuhart's first thoughts. It was very, very important to him. And if people called it the Deming cycle, they would get a rebuff, a very direct rebuff. Nope, not mine. Schuhart's. Please call it the Schuhart cycle, right? So I would encourage you to do the same. I'd like to hear from you now. I'd like to hear some questions and what you think and what your experiences have been. So have we got somebody coordinating that?
Yes, and if you have got any questions, and if you have got any questions you want to raise, feel free to raise the question or unmute yourself and make yourself visible for Jackie, and make sure that you raise your question. So Jackie, the first question from my side is mostly around the part where you talked about the sustaining the results. What I've discovered in most of the organization is that yes, we implement and we celebrate the success of the results, but the maintaining of those results to make sure that they become consistent. How do we make sure that we keep the results stable all the time?
Right, so that's the lock the improvement in place. And I think you need to be collecting data on an ongoing basis, and you need to be control charting that to make sure that you keep the process stable and consistent. Ideally, not always possible, obviously, but you need some kind of monitor on it, because there is a tendency to go back to the way it was before. So there'll be some people who will not agree with the improvement that you've put in place. And the question is, how do we get them to move? And how do we make sure we lock it into place? So yeah, it's that ongoing review and assess, review and assess, review and assess. So in some ways, that PDSA is not turning going uphill, it's turning in the same spot. So think about it as I'm turning in the same place. So I'm ongoing planning data collection, collecting data, studying the data, acting to make sure it stays in place. So just think of the cycle as standing in one place. Does that make sense?
I see. Yeah, thank you. I see a hand up.
There's Robert.
Oh, hi,
Robert,
Robert.
go ahead.
Hi, Jackie. Thank you for the presentation. Enjoyed it. Two comments that I'm just thinking about. With regard to the Six Sigma, the last part of the DMAIC is the control.
Yeah.
And that's missing in Deming. Is it missing
No.
or is
No,
it
it's
not
not.
necessary?
Yeah, no, it's part of the act. It's part of the act stage, right? How do you?
On the other hand, DMAIC is part of a top-down system.
Yeah.
We, the specialists, define for you how you have to work. Within Deming, it's much more the employee together with the floor manager to develop a countermeasure. Once
Yeah.
you have developed your countermeasure yourself, and you know that it's the best way to act at that particular moment, there is no way to put in controls and to send in people that actually check whether you do your work correctly. That's not necessary. So
Yeah, that's right. That's right.
and the other thing with regard to multiple changes at the same time that you made, I've seen that a lot with organizations that have ISO certifications and have their processes certified. They don't want to touch their processes at all because every time they change it, they have to go through a recertification process. So there's a whole stack of ideas that they actually want to implement. And once you start to change something, they immediately throw all the other things in there as well. That's just my 2 cents.
No, I agree. I think we've actually developed ways of putting weights on that. You know, that wheel going up the hill. I think we've managed to put weights, counterweights on it to try and bring it back down again, right? So, yeah, you've got to really think about what helps you improve and what doesn't. And I mean, I'm very much of Deming's view that improvement is, we should be teaching everybody about improvement, and we should be thinking, and everybody in the organization should be thinking. I'm not a great opponent of, you know, the Six Sigma black belt concept that improvement is based with a few people. I believe it's everybody's job to improve. It's everybody's job to make a difference. I'm surprise. I'm more of the Deming mode. You'd be really shocked about that, right?
DMAIC or Six Sigma is much, but Six Sigma is much more the old Tayloristic way of doing things.
Yeah.
Separating thinking and doing.
I think it suits the American psyche as well.
Oh, absolutely.
Yeah, I think that really does suit their psyche. But what we want is for everybody, because the improvement cycle is so great. You can use it anywhere, anytime, even in the kitchen, right? So where I come from originally from the UK, from a place called Yorkshire. And there's a thing called a Yorkshire pudding, which is a delicacy, if you want to say. But the expertise in getting the perfect Yorkshire pudding, I have put my Yorkshire pudding through the improvement cycle multiple times. And when I see a different recipe, I give it a go to see if there's anything I can learn from that particular recipe so that I can make a difference on mine, right? So it's about that hunger for learning, but it's about doing it in a way where you actually do learn. That's the difference, right? That and I think DMAIC makes it very complex. You wouldn't want to go into something simple using something like a DMAIC sample or using the DMAIC method. What I want to cut back is get everybody thinking about, well, how am I using the improvement cycle? Because I absolutely guarantee everybody uses it, right? We all use it. It's our inherent way of trying something, testing it out. Those that can't close the loop are quite interesting. Those people who've not received an education which enables them to close the loop. You see that remaining open and their lack of ability to take their experiences and learn from them. And it's actually very, very interesting to review that very hard on the person who's involved.
Okay, Dr. M has been having his hand up.
Oh, has he? Is he allowed? He's the host. Is the host allowed to ask questions? Dr. M?
I'm going to put a hand down now. But then, let me start with the Yorkshire pudding. When I was in Ilkley, and I wanted to have a dessert, right? And the best dessert that I've found that in India, everything that is sweet is called a pudding. So I went and ordered a Yorkshire pudding, and you know what I got, right? So
Yeah, it should be served with onion gravy. That's a clue that it's not sweet.
right. So coming back to where I am, because whatever Jackie has been teaching us, I've been trying to put it in nest. And I know there's a lot of fluctuation in the number of people attending, whether it's common cause, special cause, I really have no clue. But I'm in the improvement section. What we were taught, and let me talk from the Japanese point of view, because there's a lot of UK, a lot of American. Let me get Masaki Ima into that. We were told that the system is stabilize, standardize, and improve. That's what we were taught. Now, even in the stabilization stage, we did PDCA, and it was Sensei Masaki Imai who brought us into Deming, and he told us PDSA. He said CA, but then he used the word Hensai. That means to think over it. So even in the stabilized state, I never knew anything about the special cause or common cause, right? So we were supposed to stabilize, keep a standard. We kept the standard, which was the best performing process that we adopted at that point of time. And then we repeated. And that's when, Robert, we involved the workmen into it to find out which was the best way the things would work. And then we started, and then we ran it all over again. So even in the stabilizing stage, we did PDSA or PDCA that we used to call, and then we standardized it exactly what you said. We used to keep the backstopper so it doesn't slide back. And then we went on into that spiral loop of SDSA, PDSA, SDS, and we used to go right up with G. OT Jackie, this is what I learned. And
Yeah.
I'm trying to apply it on Nest. I don't know common cause variation, special cause variation, things like that.
Well, I think right at this stage, you're at the early days. We haven't reached a stable system yet, right? But it's very much in its formation stage. So
This is the
looking for a stable system might not be something that you're going to find for a while until things get into a bit of a pattern, right?
Gilly, any more into the chat?
How critical using PBC chart in study how critical using PBC's chart in study the improvement or a process? Is there any or a new way that serve the same purpose as PDC?
Right. So PBC, I would assume, is process behavior charts. I don't call them that. I call them control charts.
Okay.
But if people want to call them that, that's okay. But I know what Deming would have said about that name. I can just feel it in my water, right? So the reason that process behavior chart name came, I will just tell you, is because in the US it was seen as inappropriate to use the word control. But really, what Deming was trying to determine was the process in control or not in control, or Schuhart when he designed them. It wasn't about controlling the process. It was about determining the level of control that was inherent in the process. It's very different. I don't think there's anything that can substitute for a control chart when you're doing improvement. I'll be honest. I think because what you want to know is the change you're seeing a genuine improvement or not? Is it significantly different to what it was before or not? And the only way you can do that is by statistical analysis, and the best, easiest way is a control chart. There's lots of other statistical techniques you could use that would confuse your audience quite nicely. And that's what I don't like. The reason I really, really like control charts is because it's a really easy technique to use, and anybody can be taught how to read and interpret them in a very short period of time. You can do all sorts of other more sophisticated tests, but if you can just do a simple control chart, it's by far the best method.
And
anybody else?
Oh,
sorry.
No, I was going to say thank you, Andre, for raising that question, because I didn't recognize him for him raising the question. It's the question coming from Andre.
Yeah. Right. So, Gilbert, you asked the question: is the data showing a change? Is the change consistent over time? You don't. When you do a trial, unless you get a really big step improvement, sometimes it's going to take you a while to understand whether it's improved sufficiently, right? So you might get a trend instead of, going and breaking a control limit and being a significant change. You might just get a trend above average for a period of time. But you would have to wait for that period of time to really understand whether that was a step change or not, right? If the variability is coming down, and quite often changes that I'm putting in place or changes I'm working on with customers is to just reduce variability, right? On average, we're fine, but the variability is the thing that kills you, right? So, and you won't know that until you've let the process operate for a period of time. So I guess that's another pitfall that I didn't list, actually, that in the study phase, trying to study too quickly, not taking sufficient data, not spending sufficient time in that phase will always cost you whether you were right or wrong, right? It's easy to get a short spike or a short improvement. It's harder to make it long-term improvement. And that's really what the Shoe-Heart cycle is about, is that long-term improvement.
Thank you. Anyone who has got any other question, because I'm not seeing anything on the chat.
No, I'm not either.
Hi, Jackie.
Hi.
Hi. Excellent, excellent. Always wonderful to hear you here. One of the things that you mentioned is the ability or the inability of the organizations to find the records when they are needed.
Yeah.
Yeah. So I was just wondering and thinking loud that from your experience, what would be a good way? Because what I see is there are two issues here: the ability to store the records and the ability to find it when it is needed. Yeah,
yeah, exactly. And I was actually really interested. I was working with a company during the week, and she's given up. The quality manager has given up trying to store things electronically. And what she's done is she's got some giant A3 pages where she's put cause and effect diagrams on. And she has these cause and effect diagrams in folders at the end of each line, so that when you run into a problem, you can turn to the appropriate cause and effect diagram. There it is on the line, right next to where the problem is going to be. And she said, I know it works because I have to change those folders at least once a year because they get so damaged and dirty that I have to change the folders. So I know people are accessing the data. And there's something really, really good about that, right? About there it is, right by the process. It just enables you to go straight to it, right? And people have started putting notes on things and putting extra information in behind the diagrams. And there's something really great about that, right? And it's so simple. Those people who are involved in more IT-based systems, I've seen it done well where it's cataloged properly, where keynotes are put in against every document and it's cataloged properly. But that means somebody has actually got to spend some time putting in a system to retain knowledge. And that, I think, is a really missing piece in most organizations, right? So we talk about changing standard operating procedures. We talk about standardizing processes, standardizing measurement. But we're not very good at talking about, well, where did that come from? Quite often those operating procedures don't talk about why it's like that. They just talk about this is what you do. So, that's the why is just as important often to people.
Yeah, one example that comes to my mind, and sort of in continuation with what Robert said about ISO documentation. One of the organization many years ago had a retrieval procedure, sort of, which said sales order we will retain for 10 years and shop floor documentation we will retain for 5 years. Something. Yeah. So is it a good practice to have?
No, I think sometimes you need to retain your information for as long as possible, because you might be, interesting example. the government, local government, here we have trams, and they decided it would be really nice to pull back the vintage trams and put them, because we had some vintage trams around the place, and let's put them back in service and celebrate our tram heritage and with our vintage trams. And we were in nursing homes talking to people who were engineers of these original trams, trying to work how they worked, because all the records had gone, right? So fortunately, some of them had retained some of their original drawings and things. So we were able to go back to the original drawings in some cases, but we had to rebuild that knowledge from the ground up. And it's like, why did that go? Why was that let go of? Right? Sometimes it's not obvious, sometimes it's obvious, but people will learn and relearn the same thing again and again and again. In a company I work with, they have multiple sites doing the same thing. And I was working with one of the engineering managers, and we went to a meeting and we hit the same problem that we've seen multiple times before, know what the solution is. It's like, you're going to tell them or am I going to tell them? We're not learning as an organization. So when we're learning, we're not passing that information on. Otherwise, we wouldn't be facing this problem again. So that's obviously a problem that we've got to resolve. Right? Why aren't we spreading our learning? Why aren't we celebrating that learning and spreading it at the same time so that everyone can gain from that? And that's a challenge. The other thing I would hesitate on that was, I've worked a lot in rail, and getting trains to run on time is not difficult if you know the levers to pull. And there was a team of us, we did it in Melbourne, we went to Sydney, we knew what the levers were to pull and we pulled them. Interestingly, people didn't learn. They just learned that we knew the answers on what levers to pull. So when that team went, so did the knowledge. When we repeated it in Singapore, we did it a completely different way, where we didn't tell them the levers to pull. We helped them find those levers for themselves.
Excellent.
And yeah, and the system has continued to improve since the team has come out of that area, right? So they're continuing to improve and getting better and getting better and getting better, because they learned the tools and techniques. Now, in some scenarios, you don't have the time. In Sydney, we didn't have the time because this is going back a while. This was due, the 2000 Olympics was coming. We had a certain period of time. We had to turn the ship around in that period of time, and that was all. We didn't have time to teach people levers. We tried to take them on the journey as much as we could, but we were just lever pulling, right? So it's about time and space, but you have to help people learn. And this comes back to the improvement cycle. You need to understand what theories they have, right? So that you can then challenge them.
Okay.
Jackie,
we have got two more questions. Can we give Anand? I've got Anand online, Anand as well. Anand, go ahead and ask your question.
Yeah. So, good morning, good afternoon to all. My question is that many times in shop floor, we see that teams do not declare or discuss the solution with the seniors. They first, because they are not confident of the solution. So first they do the experiment themselves, and then after getting the results on a small batch or maybe sufficient batch, they declare it to the seniors. And so I just want to know whether such type of situations have you faced? If yes, then how to get means people to inform seniors before they are taking the confirmatory trials.
Right. So this comes to, I've been debating backwards and forwards, Dr. M will tell you this, about what to do next meeting. It comes back to a level of fear in the organization, or a lack of communication willingness. So if they fail, they don't want people to hear the failure. So that's why you do the experiment, you get the improvement, and then you're willing to talk about it. But if you fail, you've probably actually got more to say. You've actually probably got more to learn, more the organization can learn. But we don't celebrate. We don't celebrate problems, and we don't celebrate when things go wrong and what we can learn from them. And we should be, if we really want to be in a learning, evolving, improving organization, we need to be doing those things. Yeah, let's celebrate the things that went well. Don't get me wrong. Of course we do. But we also need to celebrate opportunity. And opportunity can be problems and can also be things where they haven't been successful. So yeah, it's about, there's a level of, there's a fear factor there that is getting in the way of people doing that. And that's a big subject, fear.
I know we have got
Deming had a point for it, right? Point 8, drive out. Is it 8? Yeah, it's 8. So I've got a little cartoon of all the 14 points on my wall, and it's 8. 8 is drive out fear, because it's the only way I can remember them, which number they are. So yeah, point 8 is drive out fear, and it's a huge one. And Bill talked about it in when he kindly spent time with this group just before Christmas, and it's a huge subject all on its own.
I know we've got some few minutes left, but I'll call upon Mr. Jaitinda. He's got the question, a quite interesting question, which I feel that you can do justice to as well.
Yeah,
you can go ahead.
Yeah, my question is how the rise of AI and digitalization going to change the way the organizations applying PDCA and PDSA?
Well, we've either got an opportunity to really add to it or take away from it. The question is which it does, right? People have said to me, "Oh, what do you think Deming would think about AI?" I think he would see it as another useful tool for management. But what I've seen some fantastic AI systems that can really help. And I've seen some amazingly bad AI systems where all they've done is automated an already bad process. So again, it's the way that you use the tool and how you use it. I think there's a great opportunity there to retain knowledge in an organization and retain understanding of the plan, do, study, act cycle if it's done well. But it needs somebody to design it and do it well in order to do that, right? So I think there's a huge opportunity there. The question is whether we use that tool in that way, right?
Thank you.
Do you think the same?
There are no more other questions online as well.
So
Okay.
let me just take 60 seconds. When you talk about the operators on the shop floor, the famous thing that we realize that they're not stupid. Okay, so we had to, it's not in our organization, some other organizations, they wanted to have an incentive system. So the industrial engineers came and studied the work study, etc., etc. They had an incentive system and they implemented the incentive system. So the incentive, which was the max, was around 80%. They would get a certain amount and then suddenly realize that the incentives are much over 100%. What the operators really did was when the industrial engineers were observing them, they used the traditional tools that the industrial engineers recommended. The minute they went off, they had their own tools to work. They had their own templates, their own tools, which are far more effective than industrial engineers. Faisal, don't look at me. Okay, so he's an industrial engineer. So they are absolutely great at being creative and getting things done. They have taught me how to do tool-free engineering, that how do you combine two tools together and how you can, when you do your SMED, etc. So they're absolute geniuses when you really want them. So the fear factor, which Jackie is going to take the next step, will tell a lot of things.
Is that what you would? Shall we do fear next? I mean, it's a huge subject. Yeah, you want to? That's what we're going to do. I'm open to doing different things. I was thinking about talking more about operational definitions. Now, the reason I was thinking about that was because no matter what job you're in an organization, you can use them. So whether you're at the top of the organization or the bottom of the organization, it's an incredibly useful concept.
Yeah.
Deming thought that we were really poor at it, full stop, that it's terribly underutilized. I totally agree. So I was thinking about focusing on that next meeting.
Yeah, come on. I think you all should pick it up. I remember Peter Scholtes giving a good example about operational definition about measuring whether the
I'll
bear
give you for
was-
next time. Give you for next time, Doctor. You can tell about us next time. So our next session's on the 28th of June. But if there's a subject that you really want me to talk about, then please, contact, put it in the group. I do try and keep up with the Nest messages as best I can. But if you direct it to Dr. M, it will definitely get to me. Okay, I can see I'm 3 messages behind in Nest already today, but
I know she yells
Faisal.
at me, Jackie. Oh, I'm getting it recorded, but doesn't matter. She tells me, "Why wake me up in the middle of the night?" Sorry, I didn't know the time. Like, so sorry, Jackie. Sometimes, but just blame it on my cat, right? Now it is remote. I swear.
you can't do that anymore. Your cataracts are gone. Right.
Faisal, take over.
All right.
Yeah, time to say bye-bye.
No.
Thank
time
you.
time to say see you again.
Okay, see you again. Huh? Yeah. Thank you so much,
Thank you.
Jackie, for being part of the big Nest family that we are building up. Extremely gracious of you to take time off for us every month and be with us. It's extremely nice, informative, and lot of conversations around what thoughts you share. Thank you so much. All the lovely people who made this memorable. Robert, Jim, Jatinder, Gilbert, Kamal, Dr. M himself, yeah, he brings a lot of life to all these sessions, yeah,
Awesome.
and Anendra, Gopi Chand, Lakshay, Nirjar, extremely Ayush. If I'm missing some names, excuse me for that. And we look forward to meeting you all very soon in the month of June. Thank you so much. Thank you so much.
Thank you for your time, everybody.
Thank you.